Good morning everyone. I am Tanushree Dalai from Civil Engineering branch, and today we will solve the internal analysis of this truss. So we completed the external analysis of this truss by the help of method of section, and now we will do the internal analysis. So for calculation of internal analysis, we have three numbers of equilibrium equation, that is summation of fx equal to 0, summation of fy equal to 0, and summation of moment about 0. So first of all, according to the cut section, the first part of the truss we consider. So the free body diagram of this first part should be look like this. So to solve the first equilibrium equation, that is fx equal to 0, that means all the horizontal forces are equal to 0. So in the first part of the truss, there are three numbers of horizontal members and one inclined member is there. So the force on inclined member EB should be resolved in horizontal direction. Hence, the total number of horizontal forces for this part should be 4. One is dx, another is FAB, another is your EF, and last one is your FEB cos theta. We know that the value of dx is 0, which we already calculated in external analysis. So that's why this part will be 0. Next, FAB and FEF is the direct horizontal forces and FEB is the inclined forces. So that's why we have to resolve this one. Hence, FEB cos theta is the horizontally resolved forces for this inclined member. Now you can see all the member directed towards the right. So that's why all are in positive. So we can put FEF plus FAB plus FEB cos theta is equal to 0. So here you can see all the members are unknown for us. So that's why this equation we will put as here. Now comes to the second equilibrium equation, that is summation of Fy is equal to 0. So now we can choose all the vertical forces for the part 1. So you can see here one reaction is there which is vertically upward, one loading system is there which is vertically downward, and this member force, that is FEB, we can resolve this one along the vertical direction, and the value of the force should be FEB sin theta. And here you can see the value of dy and FEB sin theta is directed towards upward, and this 10 kilonewton is directed towards downward. So that's why these two are positive in direction and this 10 kilonewton should be negative in direction. So we can put here, so FEB sin theta plus dy, that is 20 kilonewton, minus 10 kilonewton is equal to 0. So here also FEB we got, but the value of EF, that means this one EF we need to know. So for that we move on to the moment calculation. So summation of moment is equal to 0. So first of all to calculate the moment, we need a point to which about we can calculate the moment. So always remember, in case of method of section, we need to find out the suitable point to which about we can calculate the moment. So choose the nearer joint up to the sectional part. So if the sectional part is this, then the nearer point about is B. So we have to choose the point B, and moment about B we have to calculate. So that summation of MB equal to 0. And one thing is there, whenever we calculate the moment about B, we can't take the moment for those member forces which is connected to the joint B. So you can see the member AB and member EB is joined to the B joint. So that's why these forces are not considering in this part. Rest of all the members, that is vertical or horizontal, we can consider for the calculation of moment. So rest is here 10 kN, here dx, another dy which is 20 kN, and EF. Now we know that dx value is 0, so that the whole term will be 0. So only dy, FEF and 10 kN we can calculate the moment for all of this. So now for this force EF, that is force in EF, the moment about B should be FEF into 4, because this member cover the distance up to B is this distance, that means the height of the girder. And you know that in question the height of the girder is 4 meter. So that's why FEF into 4 is the value of moment for the force FEF. And the sign should be positive due to the sagging moment. Now comes to dy. So you can see this dy cover this distance here to here. That means it will cover the distance of 9. You can see in this figure. Up to this much, the distance is 9, because this much is 6 and here to here is 3. So total distance it will cover 9. Hence, the moment for the 20 kN, that is dy, is should be 20 into 9, and the sign should be negative due to the hogging moment. Now comes to this 10 kN. So it will cover 6 meter from here to here. So that's why the moment for the 10 kN should be 10 into 6, and it will give the sagging moment for 2B. So that's why the value of 10 kN moment should be 10 into 6. Hence, by putting all the moments, we got our EF value, that is the force on EF member, which is equal to 30 kN. So in this way, we calculate the force on EF member which is asked by this question. So according to this, we can solve all the forces along with internal analysis and external analysis of the truss member or any girder member by the help of method of section. So today this much. Thank you.